All right, so let's now talk about how we balance equations. Now, just a little warning here. This can be, for some kids, very overwhelming, at least in the beginning. It might seem very confusing. You might feel like you really don't have the hang of this. You don't even know where to start in the beginning. It's difficult until you do a bunch of them and you start to kind of get a pattern down pat. You start to know what to look for. You start to use some of the tips and the tricks that I'm going to cover with you. So if you do feel in the beginning of this that this is a little overwhelming, you're not alone. It's okay. Just believe that you will get better at this. You just need time, tips, and practice. That being said, the first tip that we're giving you, or the first step, is that you should use a pencil, because this is a process. This is going to be something where things don't click right away. You need a little bit of struggle time. You need to try some numbers out and see if that works. And if that doesn't work, you to try something else. Or you write a number down and then all of a sudden you realize, wait, that number's not right, because you just changed something else. So now you have to go erase that number and put something new there. So if you can, use a pencil. When you get ready to balance something, just take a moment, look at the whole entire equation, and count the number of atoms of each element on both sides of the equation, because they might automatically already be balanced. It might look overwhelming, but it might already be balanced. And if it's not, at least you know what atoms you really need to focus on. So take a minute, look at the entire equation, and figure out how many atoms are on both sides. Then you're going to write coefficients. Coefficients are the big numbers out front. So like this big 10, that tells us we have 10 waters. You know the formulas for water is H2O. You would never change that 2 to something else. So never ever change a subscript. You only change the big coefficients out front. And when you think you're done and you've written all the coefficients in their appropriate places, look at them and see if you can reduce them. If you can reduce, then do so. Like this 10, 10, and 5 is correct. If we think about how many hydrogens we have, we got hydrogens and oxygens on both sides. Here's our arrow. Here's our yield sign. So let's look at how many hydrogens are on this side. 10 times 2, that's 20. How many oxygens? 10 times 1, that's 10. On this side, on the product side, once this water breaks up, we have 10 times 2, we still have 20 hydrogens. And we have 5 times 2, that's 10. So 2010, 2010, everything's the same. This is technically balanced, but it's not reduced. So if you can divide everything through, then do so. 10, 10, 5 becomes 2, 2, 1 if everything's divided by 5. So always reduce. When you're done, I guess this should be a 4 here. When you're done, make sure you check your work. Make sure that you've gone through one last time and verified that whatever you start with is what you end with. And finally, just practice. You're going to get better at it. Now, this is a mindset that I found helps kids figure out kind of what to change or where to go first when you're balancing equations. This isn't officially in your notes, but maybe jot down a note off to the side somewhere. The mindset is, if I have extra reactants, if I have extra stuff on my reactant side, then I'm going to make more products. You can never have extras left over. If you have extras, you have to use them. So if you have extras, make more products. And the other mindset you should be thinking is, if you don't have enough reactants, if you want to make something on the product side and there's not enough reactants to start with, just like if I want to make brownies and there's not enough eggs on the counter, I can go back to my refrigerator and get more eggs. In chemistry, think about making the products with the reactants that you get from a stockroom. If you don't have enough of something, you can go back to the stockroom and get more of that same thing. Now, we're not talking about poof, creating atoms out of thin air. We're talking about going to get more that already exist and just adding that additional amount to the container where the reaction's happening. Okay, it's different than me telling you that we're poof creating atoms. That can't happen, but we can go to the stockroom and get more. So let's apply these two ideas to these problems. This first one, we start with PCl3, so that one phosphorus is bonded to 3 chlorines, and the other reactant is Cl2, diatomic chlorine. So when I want to run this reaction, I'm going to be imagining the P splitting from the 3 chlorines, and these 2 chlorines splitting from one another. So I'm going to have 1 P and 5 chlorines. And that is exactly what I need to build this. So I really just need one of these molecules. I don't need to go back to the stockroom and get any more. One is good enough. And I need one of these molecules. Remember, molecules, these 2 atoms bonded together. So I need one of these guys and one of those guys, and if I break them all down and rearrange the atoms, I can make one of these guys. This is perfect. This is balanced just the way it is. I don't need to worry about making more products because I don't have extra reactants. And I'm not short any reactants. I don't have to go back to the stockroom. I have 1 and 1. I always start with 1s. If you need to make more products, then you can make 2 products or 3 products. Or if you don't have enough reactants, instead of just starting with 1, you can go get another one and make it 2 or 3 or 4. But in this case, the way it is perfect. Let's look at this one. Now, we start off with one of these and one of these, and we can make one of these. Does that work? Well, if I take this molecule and split it, H, and that Cl, I can make this, 1H, 1Cl. But I have this H and this Cl still left. And that brings us to our first little mindset idea here. If I have extra reactants, then make more products. So I picked a nice easy example here. I do have extra reactants, and if I put that H and that Cl together, I can make another one, another one of these guys here. So instead of just making one of them, like we naturally start off with, we're going to change this to a 2. We're going to make 1, 2 of them, and then all of my atoms are used up. I didn't need to go back to the stockroom because I had the perfect amount. I just had to use them to make more products. Now this one here, this is a biggie here. I've got one of these molecules. We always start with 1s. I start with one of these molecules, and it happens to have 4 phosphorus atoms. So when I break this apart in the beginning of the reaction, I'm going to have 4 P's to work with. Now this, again, I always start with one molecule. That gives me, when I separate it, 2 H's. And I want to use that to build a PH3. I want to build one of these. Well, you probably already noticed that we have an issue here. We don't have enough H's to build even one of these. We have 2, we need 3, just to make one. So the rule is, if you don't have enough reactants, then you can go to the stockroom and you can get more. So let's go to the stockroom here. We're going to pull another one of these molecules out. So now, and I'm writing here over the top of this. You're going to see this is going to change quite a bit here, but this will reinforce why it's so important to use a pencil. So if I want to build one of these guys, I'm going to use this P, and I'm going to use this H, and this H. And I built one. Good. But I still have leftovers. I still have 1, 2, 3 P's and 1 little hydrogen. So the rule is, if you have extra reactants, make more products. So let's do that. We're going to make a second one of these PH3s. But you may have realized we ran into another problem, because we have plenty of P's, but we don't have enough H's. We only have 1 extra, and we need 3 total. So what do? We go back to the stockroom. We get more. And now I have a P that I can use to make this, and I have 1, 2, 3 hydrogens. So this guy is all set. Now I've made 2 of them. But I still have 2 phosphoruses left over. So if I have extras, I got to make more. So I'm going to make another one of these guys. I'm going to make a third one. And if I'm making a third one of them, I need more of these reactants here. So I've got to go back to the stockroom and I've got to get more hydrogens. I have plenty of P's, but I've got to go get more hydrogens. So if I get one more molecule, it's not enough. I need 1, 2, 3 atoms. That's not good enough, so I have to go get another one. So I can use up one of my phosphoruses and then 1, 2, 3 to build this guy. Well, I still have, we're almost done here, I still have a P and an H left over. So if I have more reactants, I'm gonna make more products. So here comes the fourth one. And you realize that if I want to build that, I have the P that I need, but I don't have enough hydrogens. So yet again, I gotta go back to the stockroom, pull out another set, and I can use up those 3, build this guy, and now I'm done. So I went to the stockroom a lot here. I never went to the stockroom to get a P4. I had enough of those. Actually, I had too many of those. But I did go get a lot of hydrogens. How many molecules do I have? 1, 2, 3, 4, 5, 6. So all in all, we have to get 6 of these hydrogen molecules. And if we have 1 of these and 6 of those, then we can build 4 of these. And all of our atoms are accounted for. Now, this was crazy tedious, using the pictures and going to the stockroom and pulling the images out and crossing everything off. You can do that. If that visual stuff helps you, you can draw all this stuff out on paper. But you will also get better at this. So remember the coefficients are 1, 6, 4. Let's erase those. Let's pretend that we are starting without these images. We're just looking at the symbols and the formulas. So the first thing you should do is mentally assume everything is a 1. For some kids, it actually helps to put a 1 there. But maybe write it small or in light pencil, because it's likely going to change. So if I have 1 of these, we distribute. 1 times the 4 is 4 P's. Go over here. We see 1 times the imaginary 1. It's only 1 phosphorus for each one of these. So 1 times 1 is only 1. That doesn't work. We've got to have 4. So we can't change the subscript down here. We can't put a 4 down there because that's not what a molecule contains. A molecule contains 1. So I can't put a 4 down there, but I can, and the only thing I should do is change my coefficients. So by recognizing I have 4 P's and then putting a 4 out front, I still have 4 times 1 is 4 P's. Then, if I want to build 4 of these molecules to use up all my P's, I can look at how many hydrogens I need. Do the distribution. 4 times 3 is 12. I need to have 12 hydrogens over here. So that means I better start with 12. So 1 times 2 is only 2. That's not good enough. We need this to equal 12. So what number times 2 equals 12? 6. So you're going to be going through this back and forth, looking at this atom or element, looking at that element, how many on this side, how many on that side, oh, I changed this, what else did that change? And just going back and forth until everything works out. And again, if you need to draw little images, you can. So let's do a few of these easy ones here. We have a stock room that we could always go back to, and we have the ability to make more things. So these are a few easy ones. If you want, hit pause right now and try them out, and then we'll come back and go over them. All right, now this first one. Remember, everything starts off with 1s. We don't usually write the 1s, but maybe in the learning process, you might want to. So if I start with 1 calcium on the left, well, I want to build something that has 1 calcium, no number down here, so it's 1 calcium on the right. I have one of these molecules of chlorine. 1 times 2 is 2 chlorines. And over here, I'm building something that needs 2 chlorines. 1 times 2 is 2 chlorines. This whole thing is perfectly balanced with 1s everywhere. One of these, one of those makes one of those. This next example is not. So the first thing I look at, just because it's on the left, and I'm going to start over there, is chlorine. So if I start with one of these molecules of chlorine, I get 2 atoms. So I look on the right side. What am I making with chlorine? Oh, sodium chloride. Sodium chloride only needs 1 chlorine atom. But I had 2. But I only need to make something with 1 in it. So that means I'm going to have leftovers. If you have leftovers, make more products. So you have to use up both chlorines. So you're going to take the product that you're going to make that has chlorine in it, and instead of making 1, make 2. And now both chlorines are going to be used. So I've got to make 2 of these things. Now 2 times the chlorine with imaginary 1 is 2. 1 times 2 is 2. Chlorines are good. But in order to build 2 of those sodium chlorides, I need to have 2 sodiums present. Remember, there's an imaginary 1. 2 times 1 is 2. So I need 2 sodiums. So I go over here and I say, well, in my reactant side, I only have 1 of these. I don't have 2 sodiums that I need. So what do? I go back to the stock room. And when I go to my stock room, I say I need to grab more sodium iodide. It's a pair. I have to take whatever this formula is. I can't just take one Na and leave the I behind. It has to go together. I have to get a duplicate of this. So now I've got 2 of these NaIs. And you see that there's 2 sodiums, and if I didn't see these cute little images here, I would imagine a 1 there. 2 times 1 is 2. And now that brings in another iodine to the mix. So now I have 2 times 1, 2 iodines. 1, 2. And that's great, because that's what I need to build this. To build one of these, I need the 2 iodines. So these are my coefficients, a 1, a 2, a 1, and a 2. Check your chlorines. 1, 2 chlorines, 1, 2 chlorines. 2 sodiums, 2 sodiums. 2 iodines, 2 iodines. Everything on the left is equal to everything on the right. It's balanced. Now the next one. I'm going to start on the left. I've got 2 Ks and an S. 2 Ks and imaginary 1S. So if I start with one of these and I break it apart, what am I going to use those Ks and the S for? Well, let's look at the Ks. Go over here. This is where the K is. We're going to build something that only needs 1 K. Just 1. But I have 2 to start with. The rule is if you have extras, you got to build more. So I can't settle for just 1 of these. I've actually got to build 2 of them. I have enough ingredients, when it comes at least to the Ks right now, to build 2 of these. 2 times 1 is 2. 1 times 2 is 2. Ks are balanced. Now, if I'm going to build 2 of those, I also need the 2 bromines. Remember, there's an imaginary 1 here. 2 times 1 is 2, so I need 2 bromines. I look over here. Well, that's exactly what I have. One of these molecules, 1CuBr2, gives me the 2 bromines I need. Right there. 1 times 2 is 2 bromines. So that's good. I can build these 2. So now my potassiums, Ks, and my bromines are settled. Now, when I broke this apart, I had 1S. 1 times 1 is 1S. Over here, that's exactly what I need. To build one of these things, I need 1S. And I also need a copper, which is what I have here. 1 times imaginary 1 is 1 copper. 1 times imaginary 1 is 1 copper. So everything now is balanced. And I know this looks like a mess here, but it's 1, 1, 1, 2. That's all I needed to do. Add a 2 there. Now this one, I've got 1 iron over here. Irons look good. But sulfur comes in 8. When I break this thing apart, I'm going to have 8 S's ready to go. What I want to build only needs 1. But I've got to use all 8. So that means I got to make more of these. So I'm probably not going to pull them all out here, but you can imagine I need to do this 8 times to use up every single sulfur. So I'm actually going to make, from one of these molecules, 8 of these. I've got to use every single one. And if I'm going to use up all 8 sulfurs, I better have 8 total irons to go with it. So 1 doesn't cut it. I go back to the stock room and I get more and more and more and more and more. I get 8 of these. So 8, 1, 8. That balances it. Let's look at this one. I've got N2. Over here, I want to build something that only needs 1 N. But I start with 2. So I've got to make more of my products. 1 isn't good enough. I'm going to have to make 2 of them. So 2 times the imaginary 1 is 2 nitrogens, and I've got my 2 nitrogens. So one of these is good. Now, hydrogens. I start with 1 molecule, and that gives me 2 H's. But I need to build 2 of these, and they each need 4. So 2 times 4 is 8. I need 8 hydrogens. So I need to know what, because 1's not right, so I need to know what times 2 is going to give me 8. And that is 4. So that means I got to go back to the stock room and get more of these until I have a grand total of 4. And then when I break all the bonds, that will give me the 8 hydrogens that I need so I can build 2 of these. I'll put 4 here and put 4 there. So my coefficients are 1, 4, and 2. Everything I start with is what I end with. And the last one here. The pictures kind of make this easy to look at. 2 NAs, 2 NAs. If I didn't have the pictures, I would look at my subscripts. One of these molecules has 2 NAs in it. I'm going to build, on the right side of the reactant, one of these. And it has 2 NAs in it. So Na is all set. Oxygen. I've got 1 oxygen here, because there's no number, so I assume it's a 1. I've got 4 oxygens here. 1 plus 4 is 5 total on this side. Over here, I have 4 and 1. I have 5 oxygens. So this is looking good, just making one of those water molecules. And one of these guys gave me my 4 oxygens. Look at sulfur. 1 sulfur, 1 sulfur. Little guy, yellow guy, on one of each on each side. And finally, 2 H's, 1, 2. 1 times H2 is 2. Over here, 2 H's, 1 times 2 is 2. So this, even though it may have looked a little overwhelming, when we just look at the ones as our initial coefficients, see if we need to change them, we realize we really don't. We're good here. Ones make this whole thing balanced. We don't need any more. We don't need to go back to the stock room. We don't need to make any more products. So don't feel like some of these are crazy. If they look overwhelming, it doesn't mean you're going to have crazy coefficients. They might already be balanced. So let's pause this video here now, and then we'll come back and look at some tips and some strategies that you can employ, and then we're going to practice each of the tips